Hello everyone and welcome back to MacTech 40, and today we will see this question solution of material science question that has been asked in UPSC exam. Okay, that means last week the exam that has been conducted of assistant engineer UPSC assistant engineer exam. So we will see the material science question, material science and metallurgy MSM. So the first question, that is chromium is an alloying element in an alloy steel used principally. Here the main thing, that is principally. Why principally it is written? Because to improve hardenability chromium is also added. To improve the mechanical properties at elevated temperature chromium is added. To improve the corrosion and oxidation resistance, this is chromium is again added. So which is we require hardener? So our answer would be, the correct answer will be improve the corrosion resistance and oxidation. Why? Because generally in stainless steel, that austenitic, ferritic and martensitic, there are basically three types of stainless steel, or we are generally saying SS. So wherever we require corrosion resistance in our home decor and any other place, okay, the utensils, so they are generally made of stainless steel. The door handles and ornaments that are made from steel. So that so the main element in that alloying, the main alloying element is chromium. So the main answer will be corrosion resistance. Why not improve hardenability? Because if we add other materials like the other material, that is uh, sorry. So if we add sulfur, then it is also improve the hardenability. To improve the mechanical properties at low temperature, we have to add nickel. Okay, this is for your knowledge. And improve properties at elevated temperature, we can add chromium, or we can add cobalt, or tungsten, or titanium. So these are four options. So the basic principle is, the main principle used is to improve the corrosion resistance. Next 57 number is, the compositions of the some alloy steels are under. So this is the nomenclature 18W4Cr. So here W is indicate tungsten, chromium, vanadium. Mo, that is molybdenum, tungsten, chromium, vanadium. So these are four designation of the material. The composition of commonly used high-speed steel would include. So in generally commonly used high-speed steel, which of this? So in generally whatever we are using, that is tungsten and chromium, and some portion of vanadium is added. Molybdenum is added when there is a high temperature requirement. One thing that I missed here in option C, that is chromium. I've told you here chromium, cobalt, titanium, tungsten, as well as molybdenum. So molybdenum is the main alloying element which to improve hot hardness. We are saying at elevated temperature hardness, but commonly high speed steel, that is does not require any high hot or red hot temperature or any hardness. So these two options directly get eliminated, 2 and 3. So only option 1 and 4 are the correct answer. Okay, hope you guys understand. Next is the material which show direction dependent properties. These are called anisotropic. Is easy. Homogeneous material, that means the composition of the material throughout the section is constant. Like for example, this is the material of throughout the length, and what are the composition here, that is same throughout the cross section. If you take cross section at anywhere. Viscoelastic material, that is the elastic rubber type material, that is called viscoelastic. Isotropic material, that is properties in all direction remain same. For example, if this is a block, if I'm applying the force and for the same area, then what are the stresses produced? So again, if I'm applying perpendicular direction on the same cross section area, then the induced stress would be same. If it is not, if it is dependent on the direction, then it is called anisotropic. So this is the answer. Now atomic radius of the face centered cubic crystal, that is a root 2 by 4. Very easy. How? because if you take a side face, then there is like this: one atom, second atom, and third atom. Sorry, again I'm drawing like this. So there are, this is the triangle and this is the diagonal and this is the side A. Okay, and atomic radius. So this is the R, atomic radius R, 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 and R. So using Pythagoras theorem, this is 1, 2, 3, 4. 4 R is equal to 4R whole square is equal to a square plus a square, that is 2a square. Okay, so if you take the common, if you take a square, sorry, square root, so this square will get cancelled, so it will 4R is equal to root 2a. So we have to find atomic radius, so R is equal to root 2a by 4, sorry 4. So this is the answer. Next is 60. Which of the following phase of the steel is not, underline this, not present in iron carbon phase diagram, that is Martensite? This is very easy question, you all know. Those who want explanation, then iron carbon diagram, it is an equilibrium diagram, and if you know, that is we are cooling the from liquid to solid, then there are different phases depending upon the carbon content, so that cooling is very slow. Okay, it is equilibrium at each state. For example, if the liquid steel is 1200 degrees Celsius, then when it is cooled down to 1100 degrees Celsius, then it will be equilibrium. When it will come equilibrium, then after we will cool down to 1000 degrees Celsius, then that means it is very slow process. But Martensite is what? Rapid cooling, that is present in TTT diagram. Okay, so the answer is D. Next is, the machine tool guideways are usually hardened by, so it is flame hardening. Why? Because induction hardening, why it is not, why we are not doing this? Because we know the answer of the flame hardening, but why not? So because induction hardening is what, in induction heat, in induction heater, we are putting all the bed, but what our requirement is, the surface of the bed should be hard enough such that, so that, suppose this is a V bed, side view I'm showing here. So what our requirement is, it should be tough enough in the other cross section to take the static and dynamic loading, but the surface must be hard enough and it must be wear resistant, so that frequent movement of that slideways, okay, that is generally the sliders and tool post that is mounted on the cross slide and tail stroke, so that is a frequent movement in machining. So the only surface that we required, so why do waste the energy to harden on other parts? That is also not recommended. Mar tempering is used to make the binite structure. Binite we not required, we require hard enough martensite structure. Vacuum hardening, it is not, because the full body, the full bed you have to put in the heat treatment chamber, so that is not recommended. The flame hardening is what, the bed is placed in workshop and that is called nitriding. Okay, the ammonia is placed and it is heated up, so the cyanide gases are produced. So that is one other drawback, but we are generally using this. So, and it is flame, that is a flame used in gas welding, that is with the help of flame, that is hard and just rapid cool down, so that its surface will become very hard to absorb the wear resistance. Okay, so answer will be B. Now second 62, that is twin boundaries are which type of crystal defect? That is surface defect. Why twin boundaries? Because that is two boundary is not like linear, that is the two surfaces which are twinned together, that is somewhat at angular displacement, like suppose this is the first surface and this is the second surface, so these two surfaces are merged at an angle, or like this. it is spread up, or maybe like this. Okay, what is the point defect? Let us see other options also. Point defect, that is Schottky and Frankel, one atom is missing. Line defect is what? At one particular line the number of atoms are missing, that is the twin boundary, the whole boundary, that is atoms are missing, so that maybe boundaries are getting intermixed or get deflected. So the answer will be C. So these are the questions. The level of question is I'm putting in easy section. Okay, so thank you guys for watching this video, and which subjects you want next, come answer in the comment. For example, if you want SOM or machine design or whether any subject, just answer in the comment which subjects answer are those subjects which are highly on demand. That means the subjects whose comment are more, then I will take the next subject. Okay, so thank you guys for watching. Keep studying, stay focused.